Okay, so here we go for the next for starters. This is going to go with chapter 7.1, and this assumes prior knowledge of the other mechanics chapters for the A2 mechanics. So here we go. The aim here is that you have a go at them, or read the question, pause, have a go, and then look through the solution. So we've got a mass of 20 kilograms resting on a horizontal plane, a force of 150 newtons. So that's 150 newtons applied at 30 degrees to the horizontal, and that mu is equal to 2/3, and we need to find the acceleration. So first thing to do is to pause, have a go, then look at the rest of this little section. So we are going to put on the additional forces on the diagram. We get a normal reaction, we have a friction, and then because it's on a horizontal plane, we do the standard things, resolve vertically. So we get R plus 150, and we can break the force into its components in the usual way. So we've got horizontal component, which is 150 cos 30, because it's next to, adjacent to the angle, and we have 150 sine 30, because it's opposite the angle. So therefore, when resolving horizontally, you've got 150 sine of 30 minus 20g is equal to 0, since it's an equilibrium. So R is equal to 20g minus 150 sine of 30. Sine of 30 is approximate, well, sine of 30 is a half, so that's 75, so that's 125, probably closer to 121 newtons. You can tap it in a calculator just to check. If we resolve horizontally, we get 150 cos of 30. Well, not actually resolve, it's going to be apply N2 because we've got an acceleration. So apply N2. Horizontally, we get 150 cos 30 minus the friction is equal to 20a, and we should have put the acceleration on up here. So then, what have we got? Cos of 30 we know is root 3 over 2, so that's 75 root 3 minus the friction equals 20 lots of the acceleration. Since sliding, friction is equal to mu r, so we've got mu as 2/3, r as 121, as 121 from above. Yeah, that's coming from here. So we get 242 over 3, which is roughly 81. So we get 75 root 3 minus the 242 over 3 equals 20a. So a is going to be approximately 75 root 3 is 75 plus just over 2/3, so 125 minus 80 is going to give us, I don't know, that's going to come out to be about 2.3ish metres per second squared, but you can check that on a calculator. Okay, second example of work we've done before. Yeah, so this is our second starter question. We've got a horizontal plane that's smooth, a mass of 10 kilograms sat on the plane, connected by a light inextensible string to two other masses, one of 7 kilograms and the other one of 3 kilograms. Let's say, if we call this A, B, C, and we call this TA and this one TC, we're going to say find TA, TC, the acceleration A, and the reaction at D, which we'll call that D. So here we go. We're going to apply, well, let's put the rest of the forces on. So first of all, we've got 7G acting down there, and we've got 3G acting down there, and the acceleration here is going to be up, the acceleration across the top, and the acceleration down the side. So you're going to apply N2 in the direction of the acceleration, which we've got to keep positive all the way around. So we're going to go up here. So we've got TA minus 3G equals 3A, the mass times its acceleration. So that was on A. On B, which was here, we've got, let's put the extra forces on the diagram, TA and TC, because the strings are light inextensible, so we get TC minus TA is equal to 10A. And on C now, so that was horizontally, this is now downwards, so we get 7G minus TC equals 7A. Adding is going to give us 4G because the TC's cancel and the TA's cancel, so you get 7G minus 3G is 4G, and here we get 20A. So A is equal to 4G over 20, or G over 5 metres per second squared. Once we've got the acceleration, it's easy enough to find TA. We just substitute back into the top equation. So TA minus 3G was equal to 3 lots of A, which is G over 5. So TA is equal to 3G plus 3/5 G, which means we've got 18 over 5 G newtons. And TC, using a similar substitution, we're going to get 7G minus TC, so 7G minus TC was equal to 7 lots of A, which was G over 5, so TC is equal to 7G minus 7G over 5, that's 35 minus 7 is 28G over 5 newtons. So the reaction at D, we're going to get, and probably best just to do the direction using a diagram, that's going to split the angle in half. So we've got TC acting here and here. And we're going to resolve in the direction of R. Resolve in the direction of R. So we get R minus 2TC, and this angle split in half, so that's 45 degrees. So minus 2 cos 45 times TC equals 0. Just run out of space on the side of the page here. How do I get that to go down? Nightmare, what's going on here? Nearly finished it anyway, so R. There it is, keyboard down, found it, sorry. So R is equal to 2 cos of 45 times TC, which is 28G over 5. So we've got 48 over 5G times cos of 45, which is root 2 over 2. So the 48 over, so we get 24G root 2 over 5, which you can tap in a calculator. What's that going to be roughly? 50, 70 approximately, but you can check it on a calculator. 70 newtons, and the direction is defined by the diagram above, 45 degrees above the horizontal, the direction of the plane. Okay, the third starter for today is one of my sort of favourite questions that comes up in the exams, and we're going to develop this across the starters over the next few lessons. So if we project something from a point up on a cliff at a speed of, say, 30 metres per second at an angle, say, of 60 degrees. And the question is fairly simple. Find the speed of the particle when it is travelling in a direction perpendicular to the angle of projection. Right, now, if you've not seen this before, you might struggle initially to start with, but it's very straightforward once you understand what's going on. So don't worry if you can't get it this time. It's going to come up a few times over the next few lessons. So let's just add that curve on. And so say that's the point where it's perpendicular. That's the horizontal plane. We've got an angle of 60 degrees. That was how it was projected. So it now must be going at 30 degrees to the horizontal. So that's fairly straightforward. So all you've then got to do is remember one key fact, that the horizontal speeds must be the same. So this distance here is either v cos 30 or using the projection one, it's 30 cos of 30. And since horizontal speed is constant,